We're continuing with the next type of adsorption chromatography, thin layer chromatography. So thin layer chromatography, the stationary phase is going to be adsorbents like silica, alumina, cellulose. But the difference between this thin layer and column is the fact that in this case, the stationary phase is spread on a thin plate. So that can be of any size, but the thickness of the stationary phase is approximately zero point 0.2 centimeters, and a solvent which is applicable to the particular mixture is used. So basically, we will coat the plate with silica, assuming we're using silica as the adsorbent. Then about 2 centimeters, we put in the mixture. And when the solvent basically, and this is then dipped into the container, which has the solvent at the bottom. So because again, similarly, adsorption takes place, the ones at the bottom gets absorbed to a greater extent than the ones on the top. So it gets carried upwards. The one more very important thing over here is, in case of thin layer chromatography, when it's not, if the substance is not is having its own color, then we can directly view the plate and understand like to which extent that particular substance has moved up to. But there are some substance compounds which do not have their own color. Then we basically expose it to substances like iodine, which basically give that compound a color, and then we'll observe it, and then we measure the retention factor or the RF factor. The RF factor or the retention factor is basically the comparison of the extent to which a particular substance has moved up the plate compared to the solvent. So here we have two substances. Let's assume this is X and Y. So X has moved to the distance A, whereas the solvent is moved to L. So this is the overall distance the solvent has moved. So the retention factor would be A, that is the distance moved by the substance from the baseline, divided by L. Now, if suppose this particular distance is B, then the retention factor of the red spot would be B by L. So there is a similarity of between thin layer chromatography and column chromatography in terms of adsorption. That's the principle. But the method itself, this is more to do with checking to what extent there are mixtures present and like what are the components of the mixture, whereas that the other method, that is column chromatography, is usually used to separate those components into the individual ones, or rather separate the mixture into the individual components. So with that, we complete thin layer chromatography. Again, here we're taking basically a plate, dipping it into silica, coating it with silica, and then 2 centimeters approximately above the bottom, we put in the mixture, and then we dip it into the mixture, dip it into the solvent so that it's only touching at the bottom, and then we let it run. Excuse me. In this case, we're basically comparing to the extent to which various substances have moved compared to the solvent's movement. So yeah, so the retention factor is basically the distance moved by the substance from the baseline divided by the distance moved by the solvent. With that, we complete thin layer chromatography. In the next video, we'll be talking about partition chromatography.